Doesn't seem to work. Dobre utro. Yeah, sorry about the accent. My Croatian is not fluent, obviously. Thanks for having me here. Bronco told about nice stuff, Java 9, Java 10, microservices, whatever. Today I would like to tackle something quite old, like perhaps dating back from Java 1.2, that developers might not be aware of, and that is sad because it's a huge problem. Perhaps I might introduce myself. I'm Nicolas Fränkel. I'm a developer, I'm an architect, I'm a consultant, so I'm whatever the customer asks of me. Like last time I installed and configured an Elasticsearch cluster. I don't know why, I just was asked to do that. It's not part of my job, but I mean, this kind of, you know what I'm talking about, huh? Yeah. I mean, it's fun. We have a fun work. I've been working in Java since perhaps less than 15 years, but not by much. And yeah. So you might know about this trick. You have this class, foo, which has a private field that is supposed to be private, right? But for whatever reason, oh, I was sure it didn't work. Now it's the fun part. Thanks for telling me. Feedback is important. Better? So of course now everything is broken. So yeah, you might know about these snippets. Huh? You have a class which has a private member and you need to access it. But you are not meant to access it. I mean, it's private. Still, you need to access it. So who never used the reflection API? Who doesn't know about it? The photographer probably doesn't know about it, but she's too shy to tell anything. Who never used it? Never. So I assume everybody uses it. Everybody uses it because it's very easy to do. It's very practical. And of course, there is nothing wrong with that because it is part of the GDK. And since it's part of the GDK, it's supposed to be used. And of course, it's not only used by, again. No? Oh, yes. What do you mean? Ah. Thank you again. Better? Thank you very much for your feedback. So it's not only used by developers, it's used by frameworks and libraries, it's used by Groovy, by GPA, by Hibernate, by a lot of stuff. And I mean, you can do a lot of things. You can do good things, you can do bad things. And speaking about bad things, well, who can tell me what this kind of stuff does? Yeah, very bad things. Actually, very, very interesting, but in the end, it's bad things. The first time I was shown this snippet, I was mind blown. I said, no, it's not possible. Basically, you are using the reflection API on the reflection API itself. Because a field is a class. It's a class. So it has a type attribute. And you can change the type of a type. Meaning that what I defined as an int, if I run the snippet, and now it's a string. I can change the type of a type. What I defined as an int is now a string. I mean, it's completely crazy. You can do very, very bad stuff using the reflection API. And only with this little line, set accessible, that's the magic API. If you cannot access something in the Java language, in a library, you use set accessible, and everything is open bore. It's free. One line of code breaks encapsulation. And as I said, a lot of things is possible. You can make network calls. Now, with the latest API, you can easily compile Java codes. So you've got a text file, you compile it on the fly, and then you run it. Do you see where I'm heading to? It's a problem. It's a security issue. But you will tell me, Guy, that's not an issue, because we've got all those safeguards around. We've got static analyzers. Okay, might be the case. Might be the case. But does it really catch this kind of stuff? I mean, if you are trying to create a rule that you shouldn't use the reflection API, probably you will remove it because everybody uses it anyway. And in the bytecode analyzer, you can still check some stuff, but I'm not sure everybody uses findbugs. Who uses findbugs? Okay, a few hands, like perhaps 6 people. And we have code reviews. That might be true. You have code reviews. I hope you have code reviews. But you probably have to write code before you read it, so you might not have so much time to do really good code reviews. Also, the issue is that it might not be in the code itself, but in a library that you're using. And not even a library that you are declared in the POM, but a transitive library somewhere down the line. Hey, but we have security teams that can handle that. Who here has security teams? 3 hands, 4 hands. Yeah, my experience is, well, not everybody has like teams dedicated to security, but when you have one, in general, they are just looking at compliance. They are following the process. They are not technical. They don't understand anything about technique. They just follow the process. It's secured if you follow the process. And the one who are technical, they don't have enough time to check everything. So it's an issue, right? And perhaps you know about this stuff called steganography. Steganography is just like a very nice term to tell that you can hide information inside information. Like you have a movie, you can hide an image inside, or you have an image, you can hide text inside. So if you have code review and I send you an image, what can you do with the image? You can check that the image is nice stuff. So let's do some demo for that. I have this nice piece of code here. It's a bit big. But basically what I'm doing here is again, thank you very much. That's code anyway, so it's not very interesting. So in the code here, what I'm doing is fuck yeah. Okay, it's a bit long code, and the important bit is not there. But basically, what I'm doing here is I'm reading an image, I'm extracting something out of the image, which is code. I'm compiling the code on the fly, and I'm executing it. It's a bit troublesome. But it works. So here, if I'm trying to read, for example, this nice image, oh yeah, thanks. I knew it. If you do a demo, if you do anything, if you make a presentation, have cats. Cute little cats. It works every time. So this cat is harmless. But now if I try to read this PNG image here, so I will just read the image. And here you can see that it's written something out of here. Now what I can do, I didn't write system.out.println hello from Javantura. So I want to show you that how it works. I will write another message. So I can take a very stupid file like here, and I will say hello from Javantura v5. And I will create my new image. And now if I run the image reader again, there should be another, yes, here. So just to show you that I took a simple text file, I waved it into the image, and after that, I read the image again, extracted the text, compiled it as Java class file, and executed it. So regarding the safeguards that I told you before, can any of the safeguards handle that? I'm not sure. I'm really not sure. Because if I was a bad guy, now obviously I'm a super good guy, right? If I was a bad guy, that's how I would handle it. I would create a new library called image reader. And of course, it would read images. But I would add just a little bit of features. And then I would put it into my POM, say I want to use this library to read images. And when I want to send some code, I just bring you the picture of a cat with the message inside. And then, when you run the code, when you execute the code, I would do bad stuff. It's super easy. It is really, really very easy to achieve that. Anybody can do it, even I. But you might remember, if you are not that young, that at some point we had applets on the JVM. Who remember that? Half the room. No, I'm getting too old for that shit. Yeah, and the good thing about applets that basically they were meant to run on the client machine. So basically you had your browser and you downloaded Java bytecode, and it was meant to execute on your JVM locally. And of course, people realized that it was a bit dangerous perhaps, and you wouldn't allow this code to do bad stuff. So you had to run into a sandbox. So you have two modes. You have the code mode, which basically you are used to. You can do anything, reflections, steganography, whatever you want. And you have the sandbox mode. And the sandbox mode is meant to protect you. And it's very easy to activate the sandbox mode. The sandbox mode is just another fancy name for something called the security managers. Who knows about the security manager? Okay, you are in the right room. Okay, that's good. And you should always think about it. So you can run security manager by just passing a command line when you just run your Java process or through the API, but it's better to use it on the command line because at least you are sure it's done. And once your security manager is activated, then you have to have permissions, like you are permitted to do some stuff. And this is written into a Java security file. I just wrote the references because in Java 9 and Java 8, there are different locations, unfortunately. And the Java security file points to a Java policy file. And the policy files handle the permissions. And if you want to use another one, you can, like again, pass a command line parameter with either 1 or 2 equal sign. 1 equal sign means you will append the permission, so you have default permission in your JVM, and you can add more. And the double equal sign means that you can replace. And normally that's what you would do because probably you have one JVM and many, many different apps on the same system. And in security, there is one very important principle. If you have been a system administrator, you know that you should apply the principle of least privilege. And the principle of least privilege is to give you the permissions to do what you need to do, but not more. Like if you are on a Linux box, you don't chmod to 777. It's bad. Because you probably don't need it. And so, on Java 9, the default permissions are very, very few. Basically, you can listen on some ports and read some system properties, not all. Very limited. And the good thing about those permissions is they are into the JDK. They are written there. So if you look, for example, the set accessible, the stuff that everybody uses to make reflection work on private members, then you can check that it's here, it's written here. So there is no way, I mean, no easy way, there is always a way, but there is no easy way to bypass that stuff. It's written in the JDK itself. You cannot do without. So it's pretty safe. For the record, I've written a lot of different permissions. You can probably check the slide afterward. I will send them. But the important stuff is this. This is the structure of a policy file where you write your permissions. The structure is like that simple. Grant code base, my jar, and then permission, one permission, perhaps some configuration for the permission, and then it's done. So let's check how we can do it very easily. I will get back to my hoops. So here I have the reflection API that works pretty well. I can access my private member. But now I can run secured hoops, and the only thing that I do is I'm activating the security manager. That's the only difference. So now if I run the secured hoops, it doesn't work anymore, which, depending on your point of view, might be a good or a bad news. Depends. What I would like to show you now is how you can create your policy file for your own application. So perhaps you know about the Spring Pet Clinic. Who knows about the Spring Pet Clinic? Okay, it's basically a demo for Spring and Spring Boot. And that's how it works. I have created this empty policy file, and I will try to launch it securely. So I just set the security manager, and I set the policy file here. And of course, the first thing that it tells me is that it doesn't work because it needs some permission. And that's good. That means that I'm really, really restricting what I'm letting my application doing. And given the principle of least privilege, I should give only this permission to my application, and then rerun it again and try to see what happens. So I will give the permission that is written here, permission. It's very simple. You just say, I want to give that to my application, and I rerun it again. And now I've got another one. And you can see that by default, I have really no permission. So here it complains because it cannot read some system property, which is exactly what I want. I don't want my application to do everything. I just want it to be able to do the least possible that it needs. So this is how you write it. And now I have another one. And now you see that it asks to write something. So I can here write it down. Now you understood I can do it the whole day, really. I can do it until I've got this file. I did that yesterday evening for fun. I have a fun life. 450 lines of code for a non-trivial application. And this is better because with the last version of Spring Boot, I did not finish and I had over 1,800. So it's an issue because every time you change something, then you need to change the permissions again. I just want to show you that it works, really. That's magical, because if you write the permission file from the beginning to the end, it's really, when you achieve that, it's really fun. You feel like you are the king of the world. So yeah, everything works. See, there is no, oh no, I forgot something. Here, for example, probably there is an exception, file permission, you see? I forgot to give this permission. And the bad stuff is that since it's generated, I must give like a Joker permission. So everything under sun reflect should be accepted. But this is a kind of stuff that you need to do. And now it's time. Now it's time to decide. You have the choice now. You can decide that to forget everything I've said. Everything is fine again. You have no problem. No security issue. This never happened. Or you can think that now that you know about it, you must do something. You have a risk, and you have to mitigate the risk. Of course, if you work in the gaming industry, it's not the same as if you work in the banking industry. But you must decide for yourself whether now you should allow your JVM in production running in God mode. And you know that it will be painful to fix, because you will need to write this permission file every time for every version of your application, and worse, for every change of your library version. And only you can decide whether, in your context, you need to do it or not. And this is the end, so I don't know if there is some time for question and answers. if you are interested, you can check on my blog, because this is just the beginning. Because, of course, now that you have your permission file working for a jar, now anybody can change a jar, replacing with its own jar, which will have the same permissions. So afterwards, you have you can sign jars and do stuff like that. I mean, if you start going this way, it's very, very interesting. And to be honest, I've never seen any customer running a security manager in production, which makes me very afraid. Very, very afraid. I've written a few blog posts about securing the JVM on my blog, so if you are interested, you can check. You can follow me on Twitter, and perhaps if you have some questions, I don't know if there is time. Where is the timekeeper? 5 minutes. Perfect, then. You have a question, or you just want to tell me that I have 5 minutes? Yes, so the question is, the comment is, it's super shitty to do, I agree, and it can be automated. Yes, it can, but there is no tool that I have found, and you're right, I thought about it. Like, you try to run your application, then you check the stack trace, then you copy-paste into the permission file, and yes, the permission file after. Be my guest. I will be very happy that you do it. Really, because I've checked, there is no such tool right now. And the good thing is, once, if you can automate the writing of the permission file, yes, afterwards, you can check the permission file. And this is much easier to audit. And because I can check. Of course, 1,800 lines of permission is a bit much. But I mean, if you are used to that, you can do it in an acceptable time frame. 550 is even better. But this is for the Spring Pet Clinic. You must understand it's a very small application. It's not trivial, but it's a small application. I don't know if your application would have such a limited set of permission. And again, it's because I've applied the principle of least privilege, meaning I only check every time there was an issue, I gave the permission just enough to get behind it, sorry. And sometimes you are super lazy, you just give a store permission. And of course, it's only one line of permission, but then you can do pretty shitty stuff. So it's not because the permission file is big that it's a big application. So be aware of that. But yeah, I would be very happy if there would be an automated tool. And if you create one, just ping me. I will be very happy to use it and to check if it works or not. Another question? Yeah.
Isn't it if you try to automate, so continuation to this question, if you try to automate the creation of the policy file, you will not read manually all the permissions that you gave. Isn't this kind of the point?
So the question is, if you automate the process of creating the policy file, I will not read the policy file itself. No, that's the point. You can automate the creation of the policy file. Afterwards, you check that this policy file works with your application, and then you can, when you do the code review, you send the application, the source code, as well as the policy file, and you check that the policy file is not too big compared to the application. I believe that that's doable. Yes, sure. But yes, it's easier to audit a policy file than the whole application.
Another question?
Yes.
What would be the advantage of using Security Manager besides some more conventional sandboxing solution, for example, Docker? Wouldn't it be much easier to run your application inside Docker instead of configuring Security Manager?
Those, in my opinion, those are two different levels. Because as far as I understand, I'm not a Docker expert, but you are running your processes isolated, but not completely isolated. You are still sharing some resources. Yes, that the difference between Docker and a complete different virtual machine. So you are still sharing some stuff. And for example, this is on the JVM level, but it doesn't prevent you from securing your resources at the system level. For example, if you allow a JVM to work in Goat mode, you would be able to use any sockets to listen or to connect. Docker solves this problem for sure, but you can also do it at the system level. But once you create your application, you don't know where you will be running into. It can be a Docker container, it can be like a real VM, or it can be a real system. You probably don't know. So it's not because you're secure at one level that you shouldn't secure the other levels, in my opinion.
It's just easier to secure via Docker.
That means that, well, Docker just means that at the system level, you have by default safeguards, bounds. Yes, sure, but you can do the same by preventing at the system level to write into any folder but the temporary folder, for example, or to connect to any port but this port. It can be also done at the same system level. Again, it's not because you secure at level A that you shouldn't secure at level B as well. But those are two different responsibilities, because probably the system administrators, they know about securing the system, but they don't know about this kind of stuff. Again, I understand this is, again, I've never seen that in production, but it makes my heart really go faster, because if I would be a bad guy and I wanted to make money, some quick money, I mean, you work in a bank, you just add libraries to your POM, and then you are done, and you can skip some cents on every transaction and get rich very fast. So if there are good guys in the room right now, you should think about it, because there might be some bad guys in the room right now as well. I'm not naming anyone. Other questions? Okay, thank you very much.
Thank you.